While starting the Start Pro, so we have to click on this new project. So after clicking on new project, the dialog box will be visible like this. Click on that space and give a file name as your USN, and also you have to mention your location, the path file saving location, and also you have to mention the length units also and the force unit also. Length should be in the meter, force should be in the kilonewton. After that, click on that add beam. So once after clicking on that add beam, the grid will be visible like this. So this is in the Z plane. So when it is Z plane, so bring it into a normal plane. So for that, there is a yellow shades box are visible here, no? So click on that visible box. So when you click on this box, here your grid will be in the plane mode only. So here the x-axis it is in the 10 meter span, and also the y-axis it is there in the 10 meter span. So if you want to edit that, go here in the edit option. Okay, so once after go to edit option, here you can increase your x-axis and you can increase your y-axis span also. So it depends on the span of the beam which you have it. So and also you can give a spacing also. If it is 1 meter spacing, you can give 1 meter. In case if the spacing is 1.5 meter, you can give 1.5 meter. Here I have taken one sample problem. So in that sample problem, you can draw a beam. So while drawing a beam, so my first problem what it says that, so take a grid. So the span of the beam for the first problem, it is 1 to 6 meters the span. So you can add it that. Okay, so click on that snap node beam on from 0 to 6 meter. Look at here, the span of the beam is 6 meter. So after that, so go to a normal plane. So close that dialog box. So you will directly go into a normal plane beams. So after that, what you have to do, you have to assign the type of material to this beam. So for that, what you will do, go to a commands. In that, so select a member property. So here the nodes are whatever the nodes you have given, no, because it will work on the finite element method. So for that, so this dialog box, either you can work on the grid system also, or you can work on this node system also. So for that, what you have to do, you have to define a material. So for that, what you go to a commands, go to member property. So in that prismatic, select prismatic. Here since I am doing it for the beams, so my section of the beam is rectangle. So here we have to give a section of the beam, depth of the beam and the breadth of the beam, 230 by 450. Here you have to be very careful while giving values of the YD and the ZD. Okay, so after that, once it is defined, so you have to select the entire beam and give an assign. So after that, what you have to do, you have to give a support. For that, go to an again command, support specification. In that support, so you have to just be careful while giving that support specification, because in case if it is fixed, you have to give a fixed beam only, there fixed is there. And if it is a roller, so that time you have to give a simple support, enforced but is there. So because in the problem I am showing it that number of reactions, support reactions. Okay, so now after assigning that defining the material, defined material, and also after assigning the supports, you have to assign in a loads. Okay, so here we will be having in a two types of loads, that is dead load and also in a live load. First I am defining with a load case 1, that is dead load, and the second one is load case 2. I will make it as a live load only. Dead load, any material will be having its own weight, so it means that it is a self weight. I have taken it as a 1 kilonewton per meter, and also -1, why I am giving it is just because it is acting in the downward direction. For that reason I am giving it as a -1. Okay, so after that we have to deal with a live load. You can be careful that, so in case if you have not assigned, look at that self weight, it is indicating in the red color. Okay, it indicates in the red color. In case if you have assigned already, so that time it will show it in a green color. So now the type of the load which I have it is in a uniformly distributed load, and also that load it is acting on the member. So for that I'll select that, again go to a loading. So there go to a member load. So there uniformly distributed load is there. So there in the W1, no, you have to give a value, the intensity of the value, whatever is there, so that you have to give it. And the D1 and D2 distance are there. Now look at this, intensity of the load is 30 kilonewton per meter, and it is acting throughout the member. Look at that. And the span of the beam, it is 6 meter. It means that, so d1 d2 distance, give the d1 distance starts from the 0, and the d2 distance, it is 6 meter, because throughout the span it is distributing that. So now select that entire select that load and select the entire beam, assign to selected beams, give assign to selected beams, give yes. Okay, so after that, look at the difference. Earlier, before you assigning it, it was indicating in the red color. Now it is indicating in the green color. It means that you have assigned it. In the same way, you have to assign the live load also. Look at the live load. After assigning the live load, so it is bringing this. So here is an arrow column. So there you can make it as a very small, in case if you want to